My name is Andy Grimes. I'm the Cloud Services Go-to-Market Lead for Azure Red Hat OpenShift, or abbreviated as ARO. I'm going to do a quick conversation about modernizing legacy applications with generative AI on Azure Red Hat OpenShift. So this will be a short 15-minute presentation. This will be available at Microsoft Ignite in Chicago. This will also be available posted online afterwards. Okay. So again, generative AI is obviously the hot topic in the industry. We're seeing an enormous amount of interest in generative AI. The models since ChatGPT launched, it's become extremely popular. But really, open source technologies have taken over the generative AI space, with many companies producing models such as 𝗦𝗲𝗀𝗀𝗶ecie, IBM Granite models have been open sourced, and Red Hat has technologies we're releasing. But there are many other ways to consume generative AI chat models, from code assistants to Azure Copilot, for example. But Hugging Face is an excellent website to go out and experiment on this. But a lot of times we're trying to find out how to integrate these generative AI technologies into our applications and into our application modernization strategy. So this brief discussion will talk about where Azure Red Hat OpenShift fits into this. So one of the big problems we're seeing in the industry is the difficulty in operationalizing AI, as we are seeing a lot of challenges with going from the potential of the technology using generative AI models to do chat bots, to generate content, to generate video, etc., to turning them into business safe and business ready applications. So 87% of data science projects never make it into production because the ability to prototype and do the first pass demo is definitely there. And for example, Hugging Face website actually has some spaces where you can go prototype things. But more importantly, turning it into a business safe and business ready application will oftentimes involve building a machine learning pipeline and building a DevOps pipeline to basically package up and container it or gain the benefit of it through a cloud native applications that's usually accomplished through a DevOps process. So the more operational efficiencies you can build into this, the better. So Azure and Microsoft and Red Hat have had a long relationship. A lot of trusted global partners, a lot of things that we've done together, integrated support options and technologies. So Azure Red Hat OpenShift is in fact an excellent technology as a partnership, as a first-party service in Azure to help accelerate these generative AI projects. So what is Azure Red Hat OpenShift, or ARO is how we abbreviate it? Really is it a managed service of OpenShift available in Azure, and it's designed to deploy as one click, minimal clicks with automation, and deploy a standard best practices deployment available immediately. So typically in under 30 minutes, you can have a cluster up and running. Everything's available, and it's just as if you're running OpenShift on-prem with everything pre-integrated. It accelerates your time to value. It gives you better operational efficiencies because anyone who uses OpenShift anywhere can immediately be productive on it, as well as code and applications can be migrated to it and deployed on it quickly. We want you to focus on innovation, and we also want you to have potential hybrid cloud flexibility, which means engineers that are used to using OpenShift on-prem are able to use it on ARO immediately, so you can move development resources and generative AI resources between projects seamlessly. So again, key things we want: it's a first-party solution. It's integrated with Azure developer tools. It's got a joint engineering and support agreement. It's built to have security and resiliency across multiple availability zones and regions, so it adheres to the default capabilities. It's also fully integrated into the Azure billing, Mac programs, etc. So you're able to very quickly utilize it as if it was any other Azure service. But within the portfolio, the intention is Kubernetes itself is an open source free project. But typically, Kubernetes is just the start of a project. It is a container orchestration system, but typically you have to layer other things on top of it. Many of those are based on open source technologies. So in this case, we're showing monitoring, service mesh dev tools, registry metrics, logging, CI/CD. If you're using a generic Kubernetes, you have to integrate all those things. What OpenShift does is pre-integrate all of those open source projects and basically makes them enterprise safe and enterprise boring. So they're available right away to deploy and use. What ARO adds to the equation is SRE support and customer success support for these deployments with 99.95% uptime guaranteed as an SLA, as well as hourly billing and adhering to your billing options in cloud. but also the ability to integrate with other Azure services so that you can really consume OpenShift as a managed service in the cloud. And if you're an application team or a data science team, you may not want to be a Kubernetes expert and manage this, but in many, many situations, you're going to find that you're going to require a managed service. You're going to require that models be deployed in a cloud native containerized application is how they're going to be consumed by the end user. So we typically associate this as do-it-yourself Kubernetes is more of kind of a build it yourself. AKS is kind of a add just what you need as kind of a build it platform that builds up from other services. Whereas OpenShift, and particularly ARO, is a pre-integrated solution that we often refer to as a turnkey option, so that everything is available right after it's deployed. So again, this all integrates with other Azure services, particularly DevOps, Azure Arc, for example. Again, you can use Visual Studio, but the main thing we want to be able to do is allow you to pick and choose where we want to use the OpenShift ecosystem is fully available and pre-integrated, but you can also integrate it with your Azure services as needed, and this will become more apparent when we get to the generative AI discussions. But again, key things we're looking for is opportunities to do app modernization. We're looking at modernizing existing software, so a lot of commercial software is starting to modernize to containers. And then we're also seeing AI-enabled applications, which will be the focus of this discussion. The big thing here is for modernizing commercial applications, when you develop and deliver software to customers, a lot of times being able to deliver it in containers is safer, it's faster, it's more efficient, and future upgrades of that software will be extremely easy. So again, IBM software typically does support ARO, but we also have SAS Analytics and MuleSoft and a number of other ones that are available. So we'll talk about generative AI next, but understand that these applications may overlap with some of your generative AI projects where you may be augmenting commercial software that's deployed on ARO. But the goal here is to make it easier for application teams to consume applications as containers rather than try to build Kubernetes from scratch. So again, when we start looking at AI on Azure Red Hat OpenShift, the goal is to take that turnkey platform to accelerate that last mile of delivering a generative AI application, where we also can support the front end of working with models. And we'll go into more detail on the model side and how that integrates with ARO. But a lot of times, one of that big obstacles that results in that huge percentage, 87% of AI projects fail to deliver into production is because they fail to basically generate a business-ready application that could be published and iterated across generations. So what we're trying to do is really accelerate deployments for that last mile, but also integrate with your AI tools. We want to focus on the AI innovation and minimize the work and resources needed to manage that Kubernetes platform under the covers. And then we want to give you consistently of choice. We want you to be able to use whichever generative AI tool set makes the most sense. We do have a lot of customers using Red Hat AI, and so that typically is OpenShift AI, which we'll talk about this, but we also have our Linux AI offerings and our offerings that are integrated in. But again, a lot of these, ExxonMobil is a joint Azure customer, as well as a number of these other ones. But the really important one here is looking at use cases where OpenShift AI, or we also, Watsonx is an IBM offering that integrates with OpenShift AI as well. We're seeing a lot of use cases where we'll have HR chatbots come up frequently, customer success chatbots and customer success, for example, resume filtrations, et cetera. So there's a lot of productivity that a business can derive from these, but you're probably going to need to package up these models into an application interface, a web interface, a scaling interface, and a protected interface so that you can make sure that it's secure, it's predictable, and that you can run these as efficiently as possible. Big problems we do run into, though, is app modernization, which is where generative AI, particularly things like Microsoft Copilot, Azure Watsonx Code Assistants, or using generative AI models that you've downloaded that are specifically optimized for code to do code refactoring, code conversion, code attribution, assisting that code application modernization process. But more importantly, we may be needing to customize and tune those models, and maybe needing to deliver those models as part of applications that may be run on-prem. So again, these are kind of three of the big broad use cases. There are many, many others out there, but I find that from a business perspective, each of these is going to represent a unique challenge that can be benefited by ARO. And so what we see in a lot of these situations is DevOps is really this process of taking open source components, of building an application and then iterating on it, deploying it, monitoring it, and then in many cases adjusting rapidly and really going through multiple generations of an application quickly while deploying it in a cloud native manner so it can scale horizontally and so you can potentially publish it out to remote locations. What we're seeing with generative AI is the exact same process is mirrored the next level up in an ML ops pipeline, which involves taking preparation data, obtaining your model, whether you do your own model or where you obtain an external model, particularly an open source model that you want to tune or develop. But you'll develop the model, tune it, train it from prepared data, deploy it, maybe through an API server, monitor the model, test it, evaluate it. Your data scientists will go through their processes with it, and then retrain the model and tune the model and adjust the model for your use cases so that you can get better and increasing. So there's a whole lot of work that goes on in that ML ops pipeline phase, particularly the need to kind of monitor where did I get the model, what data did I train it with, and things like that. And technologies like Watsonx governance can help with that monitoring piece. But again, regardless of what technology you use, you will see an ML ops pipeline and a DevOps pipeline very likely coexisting and interacting with each other and integrating as they cycle through both levels. So this is a very, very important capability that you need to look at is you will have DevOps and ML ops coexisting, and that the more you could do to accelerate that last mile application publishing, the better. A lot of these ML ops pipelines are going to be built out of open source technologies. And so this is what OpenShift AI is, which is a technology built on top of OpenShift. And on ARO, OpenShift AI is supported, and it would give you this very, very tight integration with an open source consumption model. So again, these are some of the open source projects, and Red Hat does what Red Hat does well, which is candidly make these boring for business and predictable for developers to use, while also giving them a common tool set. So across projects and organizations and across deployment models, whether that's on-prem or cloud or hosted potentially in other locations, you will have the same fit features and tools available for the MLOps and the DevOps pipeline anywhere they would run. This also supports the NVIDIA GPUs, Intel GPUs, and shortly AMD GPUs, as well as potentially other ones. So this gives us that kind of a standard set of tools, a toolbox for AI, but also the ability to make it portable. And so what we see also is really we want to be able to have ARO participate with OpenShift AI, participate with Watsonx, but we also integrate with the Azure AI and OpenAI. And whether you're running OpenAI models or Azure AI, for example, Azure AI Studio for the RAG database, for the vector database under it, you want to use models that you've obtained from the Azure stable. You want to use Azure training tools and training features and Azure machine learning, for example. But in many cases, we'll find that whatever ML ops platform technology you're taking advantage of, you want to be able to iterate quickly through models and have multiple models from multiple sources, but you may want multiple deployment options, but you're going to want them to probably very, very quickly turn into a cloud native application, and ARO can assist your teams with that by accelerating that developer journey and giving you a more predictable last mile to the ROI. So where we typically Azure and Azure OpenAI and Azure AI services fit in is really giving them another option for doing a fully Azure integrated machine learning pipeline. We have seamless integration with model hosting, so we can include models in our applications. We can also publish models and work with the Azure tool sets and then convert them into ARO as we go. We have the hybrid capabilities so that models that are created on ARO could be published out to edges or other consumption options, which we are also seeing a lot with generative AI. But we want this ability to be secure and compliant by making sure that any open source technologies that are integrated into it are understood and tracked. So whether you, regardless of what AI tools you want to use, we want them all available for consumption. So again, in many cases, we'll see exactly this. We'll have Azure, Microsoft Azure AI or OpenAI models will be potentially used to train and publish models into OpenShift AI. So there may be some coexistence there as models are put into the OpenShift AI tool sets and then iterated and modeled and published into the cloud native applications developed in ARO. So look, that's going to complete our presentation. We've got some links for you. You can try a proof of concept of ARO. You can watch an interactive tour. You can also explore the learning path. So here are some quick links to get you a quick link from. But we also have virtual workshops. We will be doing one November 13th, which should be just before this presentation is published. But we will also have future workshops, virtual workshops, as well as in-person workshops. So talk to your Red Hat representatives, or look out for our websites of where we're publishing these. But thank you for your time. Appreciate your attention, and would love to talk with you further. Thank you very much.